Hello everybody, today we are going to be going over logarithms and their properties, solving equations, and evaluating. So, first of all, what is a logarithm? Well, when we say we have, let's actually put an example here, log base 2 of 32. What this is saying is that 2 raised to some power is going to equal 32. Now 32, we know, is 8 times 4, but in terms of powers of 2, it's 2 times 5. So 2 raised to the x is going to equal 2 to the 5th. Now we see the bases are the same, so what we could do is we can cancel the bases. And now we're just left with x equals 5. So that means this solution here is 5. Now, let's dive in more deep into this specific concept. Let's say that we have log base 3 of 27. Let's not even write our expression down. Just make sense of what this is. 3 raised to what power is 27? This case, it's 3. Now, let's dive into a more complex problem. Let's say we have log base 1/2 of 2. What is this? Essentially, this is saying that 1/2 raised to the x is going to equal 2. Now, there's multiple ways to figure this out. First of all, we could just give the fraction, some of that, of the x. So, I mean, we can do 1 to the x over 2 to the x, because that's how you distribute the exponents, is going to equal 2. Now, 1 to the x just cancels out to 1 in this case. And then we can just multiply by 2 to the x on both sides. So 2 to the x times 2 to the first is going to equal 1. So that means 2 to the x plus 1, given your x, your exponents. I will rewrite this over here, actually. So that means 2 raised to the x plus 1 is going to equal 1. Now, we know here that 1, to only produce 1 from 2, we have to have 0. So this means that 1 is going to equal 2 to the 0th. It's going to equal 2 to the x plus 1. So that means x plus 1 has to equal 0, because obviously these bases cancel. And now we're just left with x is equal to -1. So this entire thing is equal to -1. Now the other way to do it is just to know. So 1/2 raised to the x is equal to 2. Well, when you raise it to a negative power, it's going to reciprocate the function. So when we reciprocate it, it's going to be 2 over 1, which equals 2. So we know that x equals -1. So we can get it in both ways, just by knowing and also by solving for it as well, using our prior exponent rules, so you learned in algebra. So let's move on. Let's say we have log base, I would say, 5 of 30 minus log base 5 of 6. We're going to have to follow a rule here, and this is going to be very important to know, because this applies for multiplication and division. So if we have log base, let's say we have some base, x of y, and we're going to subtract log base x of, let's say we have some quantity z. What this is going to be log base x. So that means that the bases are the same. All we got to do is divide. But in this case, we're going to divide in the other order. So it's going to be y divided by z. So log of y over z. So in this case, we do have the same bases, so we can say that log base 5 of 30 over 6 is equal to that expression right there. So 30 over 6, very simple to calculate. That's just 5. So now we have log base 5 of 5. Now, the base and this number are the same, so that means we have this expression 5 to the x equals 5. 5, and in this case, that's 1. So whenever your base is the same as that number up top, it's going to be just 1. Obviously, unless it is 0. So in this case, this expression is equal to 1. Now, let's work with multiplication. We have some similar things going on. Now, when we have when we have this version, we're going to have, instead of y over z, we're going to have y times z. So that is going to equal that. So let's have a problem. Log base 10 of 2 plus log base 10 of 50. Now, what's going to happen is we're going to take these numbers right here, 50 and 2, we're going to multiply them together and then keep the base because our bases are the same. So now we have log base 10 of 100. And we know that this is equal to 2. So that is the solution to this one. It is 2. Now, let's work with some equations first. So, we have log base 5 of x equals 2. So the way to solve an equation like this is if we know the base, or the first thing we do when we see a logarithm, we take its base and we're going to move it down here. So we're going to move it into this slot here. So this 5 is going to go over, and we're going to have a log base. Well, in this case, the log is going to cancel. So we're going to essentially cancel out this log base 5, and we're going to move it down. So this is going to be x is going to equal the 5 below, 5 squared. And 5 squared is 25. So we know that x equals 25. So that's the solution there. Now let's move on to a different type of problem. Now, what if we have this equation? Log base x of 512 equals 3. First things first, we're going to move the x down here. So now we have x to the third. We're obviously going to be canceling out that log. X to the third is going to equal 512. And we know from basic algebra that all we have to do is take the cube root on both sides. Obviously, the x to the third and the cube root cancel, so now we're just left with x is equal to, well, the cube root of 512 is just 8. So in this case, x equals 8. You can plug it back in to check the work, too. Next, we have log base 2 of 4 to the x is equal, minus 1 is equal to 7. So for this one, we're going to have to use some special rules here with this specific problem. So first things first, it's probably best that we add 1 on both sides because we want to leave alone that log base 2 of 4x and 4 to the x. Log base 2 of 4 to the x is now equal to, well, this is going to cancel, and we're going to have 7 plus 1, which is 8. Now, we could technically move this to the other side, but then we'd have to calculate 2 to the 8th, which is not something that you should do, especially to save time. But we're going to use a rule that says log base, let's say we have a base x of, y raised to the z. That's going to be the same as z times log of y. So now all we got to do is that now when we see that we have an exponent inside of our log, we're going to move it backwards. So we're going to move the exponent backward, and we're just going to be left with x times log 2 of 4 equals 8. Now, all we got to do is simplify this because it's only being multiplied by the x. So log base 2 of 4, well, that just means 2 to what power is 4? In this case, that's 2. So we can cancel this out. This is 2. So 2 times x, which is 2x in this case. So 2x is going to equal 8. Now all we got to do, divide by 2 on both sides, and we're left with x is equal to 4. So in this case, x is equal to 4 for this problem. Now, there is a couple more things I would like to go over. So we do have some very interesting rules when it comes to this kind of thing. So if we have some sort of equation, let's say we see something like ln of 6. Well, ln, this is not necessarily a log. It doesn't seem like a log, but it is. What ln means is natural log, despite the fact that, the n comes after the l. Obviously, I have no explanation for that. But in this case, we're essentially taking log base e of 6. And e in this case is going to equal, obviously, the number 2.71828 or whatever the other values are. And it's going to equal that number, essentially an infinitely compounded interest rate. But that is a topic for another day. But yes, e, essentially, this is going to be a natural logarithm. So the natural logarithm of 6, obviously, if we could take natural log on both sides, because you can also do log operations on both sides, we're essentially going to have the fact that we're going to bring these x over. So x times ln of e is going to equal ln of 6. And then we know that ln of e, so we're essentially taking log base e of e. And when we said that we have 2 of the same bases as our number up here, this is just going to equal 1. So this in this case is just going to cancel. So we know that x is equal to ln of 6. Now, ln of 6 is some irrational number because you cannot represent it as a fraction. So this is just going to be some number. So that's what a natural log is. How about we dive a little bit deeper into that? So let's say we have ln of 1. What is that going to be? We're essentially taking log base e, so we're going to have e raised to some power is going to equal 1. So what is that going to be? Well, ln of 1 is going to be equal to 0, because e to the 0 is the only thing that's going to be able to create 1. So we're going to have e raised to the 0, and that's going to equal 1. So that means that 0 is our answer for that one. Now, how about this one? Let's say we have ln of 0. Well, ln of 0, this is actually going to be undefined, because as we said before, that the natural log, essentially, it's going to mean that we're going to have e raised to some power equals 0. And this is just impossible, because we have some number. Let's actually just approximate this number. Let's say we have 3 to the x equals 0. So this means that 3 to some number equals 0, but the problem is that if we put negative numbers in here, we're just going to get 1/3. Obviously, if you plug in -2, you'll get 1/9. So these numbers aren't going negative, but if we plug in other big numbers, if we plug in 1, and even if we plug in like 3 to the 0.1, or 3 to like the 1 like 40th, it's still going to be just the 40th root of 3, and it's not going to equal 0. We're never going to be able to reach 0 with this function. So in this case, ln of 0 is undefined. Now, there is one more concept that you will probably not use, but it is also good to know. We're going to have a change of base rule. So if we have log base, let's say 6 of, let's say 30, well, this actually has an equivalent expression. If we want to change this to some base, it's going to be log base, we can choose x, and then obviously x is chosen, and we're going to have log base x of, well, this top number is going to go first, so log base x of 30 over log base x of 6. Now, this is when you need to change this log into something else to put it into your calculator, because most older calculators, or the ones that you'll have at your school, do not have a log base whatever. They only have log buttons like log base 2 or log base 10, because those are the logs. And whenever you see log of just some number, there's two things it can mean. It can mean log base 2 of 10, or it can mean log base 10 of 10. Obviously, your proctor will have to make the discrepancy on which notation will be used on the test, but it is something good to know about the change of base rule for this one. So that's going to be it for this video. Hope everyone liked the video. Subscribe. Hope everyone has a good day, and goodbye.